Welcome to episode 1, the second episode of Python Live Lessons. In the next half hour, we're going to talk about programming in Python. So at the outset, I want to say questions are encouraged. I'm monitoring the chat. I see a question or a comment here. The main reason for me to do this live rather than post static YouTube videos as I did before is actually to have a little bit of interaction. So I will try to monitor the chat, engage with questions that are coming in, and also, if there is need for that, have some questions at the end after the half hour of the show. So welcome everyone. Ingar, thank you. Glad to have you here in this fresh attempt to start a live Python show. So what are we going to do today? We're going to pick up where we left off last week when we were creating a code sketch for a particular program. And the project that we started last week in episode 0, I thought it would be fun to start starting counting from 0, given that this is a Python focused show. I realize now that is actually really confusing, but now it's too late to go back, and I actually have to clarify all the time that, episode 1 is actually the second episode and so on. But Pythonistas get it. So we were working on a Python project called Markdown Code Exec that we're going to develop over the next few episodes, and it is going to do a very specific thing that I need for myself. So the idea is that this program that we'll create, will parse Markdown text. So text like this. I hope you're familiar with the Markdown format. Markdown is just a plain text file, and you can add text to it, you can add some figures to it or links to figures, and you can also add code to Markdown. And what you're seeing here is a Markdown style code block. The 3 backticks indicate that the code block starts. Then you have some attributes indicating that it is a Python piece of code and that we want to capture the output. That's important. Then there is the actual code that says print hello world, and then we close it. And then what we want our project to do is to actually capture that output and insert the output into the Markdown file by starting with this prefix that says underscore out. And then have the output, in this case, hello world, in another code block. So a very simple, straightforward goal, and that's what we're going to build towards in the following episodes. So what we did last week is we started with what I like to call a sketch, right? So we're actually going to do some live coding in a bit, but I'll start with a short introduction. So a sketch, the way I use the term, is a very sort of unpolished piece of code that approximately does what we want our bigger program to do. And then once we have that in place, we sort of take that unpolished raw piece of code and turn it into a nice structured module that meets all the criteria of a professional package. But we start with the basic sketch. What we did last week is the first part of that sketch. Namely, we used so-called regular expressions to take a Markdown piece of text and actually extract the code and the attributes from the Markdown. So we already have most of the text parsing done. We'll see in a bit again how that works, but basically we're already able to get the code from the Markdown text. And what we're going to focus on in this episode is actually executing that code and including the output that executing that code is generated, including that again back into the Markdown in the way that I just demonstrated on the previous slide. Now, to understand how that works, I want to introduce a few basic Python concepts. So that's the format that I want to have for this show in general. That basically we are working towards a bigger project. In the meanwhile, we will touch upon various different techniques, the Python techniques, and sort of explain a little bit of the background of those Python techniques. And the Python technique that I want to focus on today is running Python. Hi, Raptor Forever. Glad to have you here. What I want to do today is show you how you can actually run Python code in Python. So with that, I mean that you actually have a string of text that corresponds to Python code, say print hello world. And rather than type it yourself into a Python interpreter, you actually use a Python application to execute that. Now, and there are 2 main functions, if you want to do that you should be aware of. and they're called Exec and Eval, and have slightly... Is the stream laggy, Spam Mitch? I hope it is only you, but if it is not, then I'm happy to hear from other people that it is indeed laggy. It's difficult for me to say. Exec and Eval relate to two different kinds of Python code. There are so-called Python expressions, and an expression is anything that evaluates to a value in Python. And that's what you execute with eval. Now, for example, a very simple example of an expression is 10 plus 10, right? That evaluates to the value 20. And as such, it is an expression and you can execute it with eval. Many things that you don't think of as expression in Python are also expressions. For example, function calls. For example, print is a function call, right? If you call print, it's a function call. And that's also an expression. And it evaluates to the return value of that function. In the case of print, that would be none, but it would still be an expression. So most things actually are expressions in Python, and you could pass them to eval. However, not everything. Python also has the concept of a statement. And a statement in Python is anything that does not evaluate to a value. So I'm happy to see actually that the stream appears to be fine. Okay. And so what is a statement? A statement is, for example, a function definition. So you have the def keyword followed by the name of the function, etc. And that whole thing is a statement because it does something. It's an instruction for the Python interpreter, but it doesn't evaluate to a value as such. A for loop is also a statement, right? The for loop tells the Python interpreter to do something multiple times. And it's an instruction to the Python interpreter, but it doesn't as such evaluate to something. And those kinds of things you have to put into an exec call. So I hope that's kind of clear. I see that some people say that the stream is laggy, other people say that it's not. What it may actually be is that I set the latency of the YouTube stream to very low in the hope to have more interactions. But if that makes it laggy, then next time I will not do that anymore, because of course having a non-laggy connection is more important than having a low latency, basically. But for now, there's nothing I can do about that. So without further ado, let's actually go and do some coding. So I'm going to switch to my Python interpreter here, and I pop up the console, and let's take a look just at the basics of exec and eval. So, as I said, eval can be used, so I'm typing this here in the bottom, eval can be used to evaluate simple expressions like 10 plus 10. Yes. 10 plus 10. And then it evaluates to 20. That's kind of what I said before, right? So you give it an expression, you get a return value. Let's give a counter example of when eval doesn't work. So you get the idea of why exec is necessary. So if we say for I in range 2, print I, this in itself is valid Python code. However, if I execute it like this, eval will say that there's a syntax error, even though it is actually fine Python code. Why? Well, because it is not an expression. It's an instruction, a statement, but it doesn't evaluate to anything. If I say exec, it will run fine, and it will do what you would expect it to do, namely print 0 and 1 to the output, right? So I will first be 0, then 1, and we print it out both. So this in a nutshell is all you need to know about exec. It's very straightforward. But I want to show you one more thing. If I click on this, I show the Workspace Explorer. And the Workspace Explorer in Rapunzel and other similar editors show you an overview of variables that are currently living in the workspace. And in this case, it is only I, and it has the value 1. Where does it come from? Well, it comes actually from this. So exec can sort of lives in the same workspace as as the context in which it is executed. To make that more clear, say if I say exec x is 1, you see that I have, by executing this, added the variable x to the Python workspace. This in many cases is not really what you want. in many cases, you want Exec to sort of live in its own workspace and to have its own set of global variables. In order to do that, you can do that very simply by creating a variable that you can call workspace. You can call it whatever you want, but let's call it workspace. And it's just a dictionary. Yep. There it is. And then instead of calling exec without any more arguments, let's say I equals 2, we call it with the workspace as the second argument. And once you do that, and I execute it, you will see that I is no longer added to our workspace here, but rather it is added to our dedicated workspace, this little dictionary that we created for that purpose, that now contains I and it has the value 2. So I hope in a nutshell, this is all there is to it, to eval and exec. I hope that's kind of clear. If not, please don't hesitate to ask questions in the chat and I will get into it. Yeah, so with that, let's actually see how we can apply that to the code that we were working on. So what we have here is the code that we worked in the previous episode that we developed. First, we read our markdown file. I execute it by running this. And what does it? What do we do then? We read this file, demo.md, and it has these markdown blocks that you saw before, right? So here, for example, we have a code block that we want to capture the output from. I'm not going into it in too much detail. If you want, if this is a bit unclear, you can look back to the previous episode where I explained this in more detail. But basically what we want to do is execute this code and then capture the output and insert it below. That's what we want to do. Now we've already read the output, right? The file demo.md to a string that we've called md. Here it is in our Python workspace. Just the contents of that file. Let's close that. And then we wrote this piece of code that is pretty complex, that has this regular expression that is pretty unreadable. Someone, by the way, suggested after the last episode that you can also write more readable regular expression with the so-called verbose format of regular expressions. That may be something to touch upon in the future. But in this case, we have this regular expression that is very complex, but what it does, essentially, let's just run it so you can see it, is it extracts from the code all the code blocks and their associated attributes. So we use re.findIter to apply this regular expression, which you don't need to understand for the purpose of this episode. We explained that in the previous episode. We loop through the code, we extract all the attributes. If we print them out, we have, for example, .python capture, right? That lived between these curly braces. And we extract the code. So if we go back, these are the attributes that we've extracted, and they are here. And this is the code that we've extracted, and that is this. And here we have, for another code block, we have the same thing, the attributes and the code. And here at the bottom, we also have one. Ingar asks, what about concatenating two strings on the function eval? Is that possible? Yes, absolutely, that's possible. And in fact, it doesn't make any difference for eval. So if I would do this, for example, 10 plus, and I would do this as a simple concatenation, it would still work. And why? Well, because what happens first is that this expression is evaluated, and it would evaluate to a string, a single string. And then once it is a single string, it is actually passed as an argument to eval, and eval just does its thing, right? So it doesn't really matter, basically. Okay. So this is how we manage to actually extract the attributes and the code from our markdown file. What we want to do now is actually execute that code. So what are we going to do? I will walk you through. It's quite complicated what I'm going to do, but I hope that doing it step by step will show you all the steps sort of that I'm going through and make it understandable nevertheless. The thing that we want to do first is get a list of all the attributes. So I will say here the match group at, that basically gets a string of the attributes, but not split into a list. So I'm going to get attributes is this, dot split up. So what it will do, it will get a string corresponding to the attributes of a single code block and split it into a list. So that we have .python, for example, as one element in the list and capture as another element in the list. And then I will say, okay, if capture is not in the attributes and silent not in the attributes, then we continue. So what does this mean? So we have two attributes that we actually want our program to understand. The behavior of capture is such that we want to execute the code, capture the output, and insert the output after the code in the way that I demonstrated already on the opening slides. Silent is another flag that executes the code, captures the output of that code, and then replaces the original code with the output. And so they accomplish slightly different things. Imagine that the capture is mostly useful for sort of having an example piece of code and then having the output illustrated below it. Whereas the silent flag is mostly for generating markdown on the fly, so to say. Say that we want to, for example, include the version of our Python module or something in the markdown, then we can actually get that version as a piece of code that is executed, capture it, and then replace the original code by that version. I hope that makes some kind of sense, right? And if not, then we'll get back to that later. And you can ask also. And if neither of those attributes are actually present, then we don't want to do anything. So we just continue. So that's what that means. And continue means stop this iteration of the loop. So don't process this code block any further, but don't break the loop. That would be the break keyword. Rather, continue with the next iteration. That's what continue means. All right. So let's comment this. Only process code blocks with capture or silent attributes. Up. Then we actually want to execute that code. Now, how can we do that? Well, we can say, very simply say, exec up match, so our matching object. And from our matching object, we have the code part, right? So that would correspond to the actual lines of code that we want to execute, as I explained in the previous episode. And we want to actually execute that in a dedicated workspace. So, and this workspace needs to be defined. So I'm going up and I'm saying, okay, workspace is a dictionary. So this is already doing quite a bit. So basically, execute the code block. So getting the code block, executing it. But this isn't enough because we also need to actually capture the output from the code block. And right now that won't happen. Exec will execute the code and the output will just go to the standard out and it will go poof, essentially. And instead what we want to do is capture that output as a string. How can you capture output? That is a bit of a trick. I will show you how it works and then I hope that's clear. There's a module called IO that has various properties related to various modules and functions related to input-output type of things. And capturing output is one of them. Then we create a so-called output buffer. And it is io.string.io. So the string.io class will actually sort of function as a file. You can sort of put text into it, but it will sort of capture it in a buffer. And then what we can say, import sys. This may seem like complex black magic, but I hope that you kind of feel that actually doing it is not that complex. And then what we're saying, okay, sys.std out, which is where all the output goes. we assign actually the output buffer to that, so that all the output will be written to our output buffer. It's as simple as that. Then afterwards, after we've done the actual execution, we also want to restore it again. So we're going to say sys.stdout is sys.__stdout. So the actual true standard output is always available as this kind of magic property of the sys module. So sys.__stdout is always going really to the standard output. So what we're doing it here is basically we're saying, okay, we're defining an output buffer that's going to capture everything. We're going to actually reroute the standard output to that output buffer. Then we're actually executing our code. And as a result, all the output of that code will now go to that output buffer. And then we're restoring it after the fact, because we don't want to sort of disturb Python altogether, right? We just want to briefly capture the output and then go back to normal. Yes. So this is, and then basically we need to actually get from the output buffer the actual text. So output is output buffer dot get value. So the io.string.io object has a .getValue function, and it will just give you as a string all the stuff that was put into it. So it will give us all the output. So here we execute the code block and capture all the output that was generated. That's what this does. And this will work actually. And now we want to do slightly different things depending on whether we have the capture flag, the capture attribute, meaning that we want to capture the output and insert it afterwards, or the silent attribute, meaning that we want to capture the output and replace the code with the output. Two slightly different modes that our program should be able to handle. So how do we do that? Let's first actually say, okay, we need to get the start and the end of the match.end. So our match object is basically start is match.start, sorry. End is match.end. So our match object corresponds to everything that was matched. So if I go to our demo thing, if we match this whole thing, the start would correspond to this, the very beginning, and the end would correspond to this location, the very end, right? So everything in between what I'm selecting now, that is the start and the end. These are our attributes, and this is our code. So that's kind of how the match object is structured. You need to know that, right? That's something you can look up. So let's first of all, for us it's important to know where we are in the code. So we say, okay, start and end, they're there. Okay, now, if capture in attrib, then we know that we actually really want to go in capture mode. So we should insert at some point after the end, we should insert the code, the output that we've captured. So, and what should we insert actually? Insert is, first we want to have two new lines to have not put our output immediately after. Then we want to indicate with this kind of prefix that we're going to insert the output. Another new line and another new line for a blank line. Then we want to have 3 backticks to indicate that the output is also going to be inserted in a code block, followed by another new line. This is where we're going to insert our output, followed by a new line, followed by 3 backticks, followed by a new line. So you see how I'm basically writing a chunk of markdown here. And in that chunk of markdown, we're going to put the output. So output is the string that contains the output of our code. And this is a whole piece of markdown that we want to insert into our bigger markdown file. And the output will go here. Not a fan of f strings. That's good. I'm not used to f strings, but let's actually So, output. So let me actually verify in the debug window whether this is how it works. Up, F, X. Yes. So an F string is sort of a new Python syntax that sort of formats the string immediately. And then you can put between curly braces the name. You can put the name of the variable that you want in there, or more complex things, and it will be sort of inserted immediately. It's kind of reminiscent of how PHP in a different programming language seems to do that. It also does that. So basically what this means, with some kind of black magic that only works in new versions of Python, the variable output will go here. Now, and then we sort of want to actually change the markdown. So we're going to operate on the markdown. So let's say md out is md. Remember, md is our original bigger markdown file. md out is going to be the output of it. And we're going to insert this variable that I called insert into this bigger md out thing. Where? Oof. Well, md out, everything until the end, we're just going to leave as is, right? So what is the end? Remember, that's here. Sorry. Then we're going to insert, so concatenate the thing that we want to insert. And then we're going to pick up, basically, md out from where we were until the very end, right? So basically, here's where the matching ends. Then we insert the thing that we want to insert, and then we leave it as is. This in principle is good. And then we're done. So I can say continue and continue processing the next code block. But if you think about it, if we do this, let's actually do it, and then you will see whether it works. Let's hope whether it works. And we'll see that md out will look garbled. Up. Invalid literal for int with base x, it says. Oh, that's true. Oop. Okay. So there is actually that crash doesn't come from my code. That crash comes from this particular code cell that should crash, and later we're going to capture that crash. But this is intended behavior. We actually executed this code block that should crash, and that is where our program crashed here with this value error. Yep. Invalid literal, and then you see that actually comes from here. Other than that, it's been processing the code blocks. But let's take a look now at md out, which is the thing that we're creating, to see what it looks like now. And you see, it looks kind of good. Oh wait, we should actually, the output, this is what we executed, this is what we inserted, and here we have some more output. I see some things that are less nice, not that nice. I actually think there's one new line too much here. Up. Up. So before the out, there's one new line too much. And you actually see that at the end of this too, there is a new line. That's sort of, there's one new line too many here. So let's say here, output is output.trim, strip actually. Or is it trim? I always forget whether, if we want to, yeah, it's strip, I think, in Python. So basically we want to remove the white space from around the output so that we don't start with a bunch of new lines and a bunch of end lines. And output.strip, but I'm going to check whether it's actually strip or trim. Up. How can I check that? Well, strip. Yeah, that's it. It is strip and not trim. Okay. So here we're basically removing all the empty stuff around the output. All right. And so you saw that actually by and large it already works, right? So we captured the output and inserted it here. Now what would go wrong actually, but what is not really shown here, is that by inserting this output, we have changed the size basically of md out, right? We've made the markdown longer. And if we don't take that into account, then for the next code block, we will be sort of not inserting stuff at the correct location anymore. And we need to take that into account, right? Basically, if we then start to execute this code and we would insert that into the Python file, Markdown file, things would become misaligned. I hope that's clear. It sounds a little bit abstract if I say it like this. I hope that's clear. But basically, we need to account for the fact that by inserting things into the Markdown grows, and therefore, basically, our start and end markers should actually also be displaced. We need to have an offset, in other words. So let's say offset is 0. So at the beginning of before we've executed any Markdown, we can just rely on the start and the end of the match groups, as we are doing now. But as we start inserting code into the Markdown, we're becoming misaligned, and we actually need to take this offset into account. Now, what is this offset, actually? Well, this offset simply corresponds to how much stuff we insert into the Markdown. In other words, the offset here plus equals lang output, right? So we need to shift down, so to say, by as many characters as we inserted, not output, sorry, insert. That's how we need to take it into account. I hope that makes sense. I actually feel now that I'm describing all of this, that is actually quite a lot to digest for you. And as such, maybe next episode I should make it a little bit simpler. So if you have preferences in terms of sort of difficulty level, also let me know, right? So then I can adjust it a little bit. So this now we've taken care of the capture property. The silent property is slightly different. If silent in attributes, then we do something slightly different. And now that I'm typing this, I realize that this if statement is actually not necessary, because it is either there is a silent or there is a capture. Here we've already taken care of the capture, so now we can safely assume that we're actually in silent mode. Okay, so in silent mode we want to do something slightly different. MD out is we actually want to replace the original code by the output. So now we have something like this: start plus output plus. So what does that mean if I go back to the Markdown? It means that basically we're executing this and we get as output a silent cell. That's what it prints. So we have a string of output, a silent cell. Then we're taking all of this. I see that. Then we take all of this and we basically say, okay, we're going to take a silent cell and we're going to replace this entire thing, to the start, from the start of the match until the end, by that a silent cell. That's the effect that we're looking for. And that's what we will accomplish here. I see one comment, that we get back to that later. And what does that mean for our offset? How do we now need to take into account our offset then? Well, the offset needs to be incremented by the length of the output in this case. But it actually needs to be decremented by how much stuff we removed, right? So now we're actually sort of the size of the code block that we're actually replacing minus end plus not plus start does that. So now we're sort of going up by as much stuff, going down by as much stuff as we inserted, and going up again by as much stuff as we removed. I hope that makes some kind of sense. If I run this, it will still crash, but we will see more than before. Up. It still crashes with this value error that actually results from the error in our Markdown code, right? The intended error. But let's take a look at MD out. Up. Our capture, this is what we programmed before, the capture flag, and the silent flag indicates that the code should be replaced by the output, and you see that that happened here successfully. So this is a silent cell. That is where the code used to be that actually produced this output. Okay, then I see one question that is more of a comment type of thing in the chat. I think this dot strip can go wrong on right calculating of the offset. Not really. It could go wrong if we would do the strip on the stuff that we insert, but then not take it into account when determining the offset. But that is not the case here. We're actually modifying the output, stripping it, creating the insert, and then inserting it. So we're actually taking into account the strip also when determining the offset. I hope that makes sense. If we would actually, for example, do it slightly differently, where we actually would do the stripping at a different moment, then you would be right. And Ingar says the script is quite clear, but the problem for me is regex and the module RE, the regex module, and they are very difficult. Then go back and watch episode 0, the first episode, as I should always clarify, where we explain this in more detail. So basically episode 0 deals with how this particular thing is constructed in a lot of detail, and I hope that you will be able to follow it. Now, the final thing that we need to do is take into account that things can crash. So here we have a crash and we have an exception attribute. And that exception attribute indicates that we expect this cell to crash. And if it does, we should actually deal with that gracefully rather than sort of have the whole script crash as it does now. So how can we do that? Well, we can do it like this. We can say, if exception in attributes, we're going to do things slightly differently than before. Else, right? So here, this stuff is just this is the normal mode. But if we actually expect an exception, then what we do is we try this. So we try to execute the code. We accept exception SE. We expect an exception to occur. And the output that we are going to capture is actually that exception converted to a string. If no exception occurs, because we actually want to be strict, right? If we specify as an attribute that there should be an exception, but an exception doesn't occur, then something is wrong. And then we say raise value error, an expected exception didn't occur. Escape this. So what does this mean? Try means, okay, try to execute some Python code, and if a crash occurs, we capture it here as the exception E, and we turn that into the output. Else means if the try actually didn't result in an exception. That's a somewhat unknown feature of Python syntax. But else, after a try except statement, means basically what you should be done if no exception occurred, which is subtly different from putting it behind. In the sense that then it is no longer in the try block. And if no exception occurs, we're actually raising a value error here. Now we have actually everything that we want. If I run this up, no crash occurs anymore, right? Because the crash that should occur in our code is actually dealt with gracefully. And if I then go to md out, and we take a bit of screen real estate to look at it, you see that everything works. This is left alone. This thing, the Python that should be captured, is actually captured and inserted afterwards. The code that used to be here, but that should be replaced because of the silent flag, is actually replaced by the output. And for the thing that should give an exception, it should raise a value error actually, or a type error maybe. Value error, I think. And that value error is indeed shown here as the output. So that was a lot. Oof. That was very fast. Now, so I'm already 10 minutes over time, so I would like to close this episode. And for the people who are watching this not live, but who are watching this afterwards in the recording, this is where it will end. I will sort of cut the stream here.